Hi, this lecture is about NumPy, short for Numerical Python, and I'll cover here NumPy arrays and various operations such as slicing, indexing, statistics, and other operations here. So basic structure in NumPy is called NumPy array, on which you apply various functions. Imagine NumPy array as a matrix with homogeneous data stored in it. You can imagine as rows and columns of data without rows and columns names. So you may ask, why use NumPy if we have traditional or built-in Python structures such as lists with its list comprehensions and loops? The answer is that NumPy is very fast. For some operations, it's 100 times faster than traditional Python structures due to the fact that some of its algorithms are written in C, which makes it perform better. So let's see its basic functionality in Spider IDE console. First thing you have to do when using NumPy, you have to import NumPy. You remember from modules lecture that you can import library or module just typing import NumPy or import library name and then its nickname or short name, which is here NP. So here we create a list, nested list with two lists nested inside, and then next step is the creation of NumPy arrays. You create NumPy arrays by typing NP, which was a shortcut for NumPy, and then array function, passing list as an argument. So let's see what we have created. We have created an array with 2 to 5. So you can imagine 2 rows by 5 columns. Next, very interesting function is so-called arange function, which is similar to Python built-in range function. So to use a range function in NumPy, you type NP, shortcut for NumPy, and then arange and pass the number of consecutive integers you want the program to create. In NumPy, you could also slice arrays. The procedure is much like you sliced lists in Python. So you type the name for the array you created, and in square brackets, first you specify the number of rows you want the program to return, and then after comma, the number of columns to return. Here we want to return it 0 and 1 columns, 1 rows and 1 and 2 columns. Remember that the last number is not included in the calculation. Of course, you can also perform basic mathematical operations with NumPy arrays. For those that have equal dimensions, it's very easy. For others, NumPy has broadcasting technique. And if certain requirements are met, you can also perform add, multiply, and other operations with arrays with no similar dimensions. So here we create my array new array, which is a slice of my array we've created earlier. So here we want to return the value under row 0 and column 2. Remember that NumPy uses indexing beginning from 0, and column number 2 is the third column. There is also another way to make slicing in NumPy. You can also specify the row and column in separate square brackets, and you'll get the same value. But also mind that the latter way of slicing is much slower than the one I described earlier. So let's move on next and create my array new 2 array, which is also a slice of my array. But here we want to return the slice should be an array. So here we want to get the first row or row under index 0 and 2 columns, and here we get 2 and 3 values array. But also remember that if you change the slice array, then you'll change the original array. So here imagine slices as views from original arrays. So we changed the first member of the slice, my array new2, and the original array called my array also changed. You see here 5555 member here. You can also use Boolean indexing in NumPy, just in the same way we have done with Python lists. So you type the array name, and in square brackets you type the condition. For example, my array members greater than 5, and it returns an array with all the members satisfying that condition. There are many powerful functions in NumPy. One of them is reshape. In that case, when you write the array name dot the function name, here the reshape takes the dimensions you want, for example 5/2, and reshapes your array to get the dimensions you want. For example, here we reshaped to 5 rows on 2 columns. There is also a function for transposing your array, which has a short name t. So you type array name .t and you get your transposed array. There are also various statistical functions. Typing np.sum and passing the array name as an argument, you get the sum of the members of your array. The same for square root functions. There are lots of statistical functions that you may want to test on your arrays. NumPy has also sort function, which sorts your array by ascending or descending order. You can look at NumPy functions on their website, and they have many more functions which will cover your many statistical needs. To get the list of functions, you should visit numpy.org website, choose their API reference, and look at the routines to perform specific tasks. For example, array creation routines. Here you see all the functions needed for array creation. So there is function called empty, which creates an empty array. Function called zeros, which creates an array of desired dimensions with 0 values filled in. And there are numerous other functions in NumPy which cannot be covered in a single lecture. The best thing you can do is to apply some of these functions, and you do not need to memorize the names of these functions. You can refer to them when needed. If you click on the function names, you'll get all the descriptions of arguments for that particular function, and also return value definitions. On the downward part of the page, you'll find some very useful examples. If you have any further questions concerning NumPy and any other Python library, you can search in a website called stackoverflow.com, and you will find a similar question that asks some other person, and you'll find the answer to that question. The answers with green mark are the accepted answers.